Hi everyone. Tonight for your homework we are going to talk about the 5.5 notes part of them. So the 5.5 notes are about using the candidates test to determine absolute extrema, and so we're going to focus just on absolute extrema for these notes. I have 4/5 example problems, and then when we get back on Monday we'll do problems where we're asked to find absolute extrema and relative extrema at the same time. But just a reminder about absolute extrema, the absolute max, if you look over here, is the absolute highest point on a graph, if there is one, and then the absolute min is the lowest point on a graph. And so for this first one, it says find the absolute extrema of y equals 14x cubed plus 11x squared minus 4x plus 3 on -1, 1. And this part right here is really important, and we'll get back to that a little bit later. And so first thing we're going to do is we're going to find critical points, because we talked about this before, but relative min or max also could be absolute min or max, because they could be the tallest point on the graph. So for example, like if you look at this, right, like this, let's say they're pointing down. This is kind of an ugly sketch, but this part is a relative max, but it's also the absolute max because it's the highest point on the graph. And so that's why we're still going to use critical points to find places where there could be extrema. And then we're also going to talk about these endpoints towards the end. So the start of this is, our step one is always going to be to find critical points. And so same process as always, I'm going to take the derivative, and I will get 42x cubed plus 22x minus 4. I'm going to go through this part quick because it's kind of review. And then I'm going to factor this. This is kind of an ugly, this should have been squared. This is kind of an ugly factor problem, but nothing we can do about it. And then I'll do a times c, which equals -42, and the factors that multiply to -42 and add to -11 are +14 and -3. And so I'm going to factor by grouping, but if you don't feel comfortable factoring by grouping, remember you can always use the quadratic formula to find these critical points. And then if I set this equal to 0, and then I were to solve, I would set each parenthesis equal to 0. I would have 3x plus 2 equals 0, so x equals -2/3, and then I would have 7x minus 1 equals 0, and I'd get x equals 1/7. So I have two critical points, one at x equals 1/7, and then the other one at x equals -2/3. And those are places that there could be possible extrema, therefore possible relative min or max. I'm not going to use the sign test to figure out if they're maxes or mins, because it'll be pretty obvious once we do our next step which one's the highest and which one's the lowest. And another thing that you need to consider with these is the endpoints, because the endpoints could be places that there's their endpoints could be places there's absolute mins or max. So if I already graphed this in Desmos right now, and so this kind of spoil our answer, but if I look at Desmos right here, the endpoint 1, I can't point to this, but the endpoint 1 goes all the way up to, it looks like 24. And so that actually is we'll see after we do our work, but that is going to be our absolute maximum. And then this point down here is going to be our relative minimum, or our absolute minimum. So I'll show you in a second, but you have to consider the endpoints because sometimes those will be the highest points on our graph. And so my second step when I go to find critical points is I'm going to create a chart / a table. So create a table to find the absolute extrema. And so under X, I'm going to write down the places that I said could possibly be them. So I'm going to go smallest to greatest. So my first endpoint is -1, so there's a possibility I have an endpoint there. One of my critical points is -2/3, one of them is 1/7, and then one of them is +1. And if they are absolute max, when I plug them into my original function, which is up here, if it's an absolute max, it should be the highest out of all these points. If it's the absolute min, it should be the lowest. And if it's in between, we don't really care about that because we're asked to find absolute extrema. So what we're going to do for these ones is we're going to take these x values here, and we're going to plug them into that equation. And so for this first one, I'll do it off to the side, and then I'm going to do the rest of my calculator. I'm just going to plug in -1 for x. And this is what you'll do for each of them. It's a little tedious, but you're just plugging it into your calculator, so it won't take you super long. And I think I get out 3 would be -3 plus 7, which equals 4. And so I already did this earlier, so I'm just going to write down the values I got earlier, but all you're doing, if you want to do it by yourself and you want to pause this, is you're just plugging those numbers in for x. So this second one, I got 6.407. This next one, I got 2.694. And the last one I got was 24. And so now I look at all of these f of x values, which are the y values, and I say which one's the biggest. The biggest will indicate our absolute max, and then the smallest will indicate our absolute minimum. So this one right here is the smallest, so this is our absolute minimum. So we have an absolute min at 1/7, 2.694, and you can convert both decimals if you don't like the mixed. And then we have an absolute max at 1/24, because if you look right here, this is our lowest one right here. So that is how you do these problems. So I want you guys to try the next one on your own. And so I'm just going to write out the work, and you can follow along, but I'm not going to speak it out loud. So try the next one. Sorry, you can't see it right here. My computer kind of glitched out on me, but this is example 2. And the equation is y equals 3 minus 4t over t squared plus 1. And then it's still, there's endpoints we have to just consider, which is -2, 4. So I will work on these while you guys work. Okay, if you want, I just plug these into my calculator, but if you want a quick way to do these problems, Oops. You also can just use the table function of your calculator, so you can like put this in as equation and then go to your table and like plug these points in, so you don't have to plug each one in individually. If you don't know what I'm talking about, just come up to me and I'll explain it. But I finished my table, and then I have found that my highest point is at negative 2.2, so my absolute max is again at an endpoint, and that is negative 2.2. And then my absolute minimum is also at an endpoint, or no, sorry, it's not. That's right here. So my absolute min is at 2, negative 1. So those are two kinds of problems you'll see about absolute max / mins. If you need a little bit more time, just pause this. But the next problem and the next two sets of problems are a little different, and so you'll see why in a second. But this next one says find the absolute extrema of f of x equals negative 3x to the 4th power plus 8x cubed plus 8x squared. And so what's interesting about these ones is there's no endpoints that is helping guide you. And so what you need to consider if you do these problems is there still can be absolute extrema, but you need to know generally what does the graph look like. And so this is a pre-calculus skill where you are asked to determine the end behavior by just looking at the equation. And so what you consider is you consider the leading coefficient, which is the coefficient on the variable with the highest degree, and you consider the highest degree. So because the highest degree on this function is an even number, that means that my end behavior will either both be going positive or it will both be going negative. And then because my leading coefficient is negative, that means that my function is going to start off negative. And so my end behavior is going to look like this. This might not be exactly it, but all I know is that my arrows, because it's even, are both going to go in the same direction, and because it's negative, they're both going to go down. And so looking at this, what I can tell is that there will be an absolute maximum. I don't know exactly where it's going to be because this isn't my exact graph, but there's not going to be any absolute minimums. So I'm going to write no absolute minimums, and that is because my function is going to negative infinity for infinity. So there's never going to be a smallest number because it's going to continue to go down forever, but it doesn't go up forever, and so there will be an absolute max. So as I do this problem, I'm going to find the critical points, but I'm only going to consider the highest number because I can tell based on this that any of the lowest numbers would just be relative mins, not absolute minimums. And so my process is going to stay the same. And then when I get to the candidates test, which is like when I put it in the table, that's when I'm only going to consider the tallest one, not the shortest one. So I'm going to go through this quickly. The factoring problems on here are kind of a lot of work, but I apologize. So I'm just factoring and trying to find the critical points first. I'm going to pull out a greatest common denominator, or greatest common factor of negative 12x. So I'll get x squared minus 2x plus minus 3. And then I'm going to factor that. X minus 3, x plus 1. Set that equal to 0. Oops. Okay. I try to put these in order from smallest to greatest. So negative 1, 0, 3. So those are my 3 critical points. And I did that really quickly, so if you need any help, just let me know. So that was my first step, and then I'm going to plug it into the table. So x, f of x. So these are the 3 possible places there could be an absolute maximum. There could be at negative 1, there could be one at 0, and there could be one at 3. And then I'm going to do the same thing I did last time. I'm going to put this equation in for y equals, and then I'm just going to use the table on my calculator so I don't have to do this 4 times. It will make my life easier. And again, if you don't know what I'm talking about, see me on Monday and I will explain. So I get 7, 0, 135, and I knew there was going to be an absolute max based on my graph, and so this one right here is it. So there's an absolute max at 3, 135. And I will do the last one for you to check your work, and that's it. I'm filming a video. But I don't have to talk anymore, so just don't say anything out loud. Sorry, guys. So this is an example of one that has no absolute max because it goes up forever. But there could be some absolute max. Okay, this last one is an example of one that has no absolute extrema, because if you were to imagine this graph, the leading coefficient is 1, and so it's going to be like generally positive, and then this is odd, which means the arrows will go into the behavior will go into a different direction. So this sketch looks like this. If you notice, it will always go to infinity forever, and it will always go to negative infinity forever, and so because of that, there will never be one highest point or one lowest point. So this is an example of a function that has no absolute extrema. And that is it.